The whole idea is to remember that you can make a statement about the slope. Usually it's going to be something like it's constant and it's positive or negative, or it's increasing or decreasing, and then you replace the word slope with what it represents. So the first video we had, our first slide, we look at the x versus t. All right, we see position versus time. The slope of position versus time represents velocity. So first, it's a flat line, so the slope is 0. If the slope is 0, replace the word slope with what it represents, and the velocity is 0. Okay? Also, it's a straight line, so the slope's also, it's not curving up or curving down or anything. It's constant. It's a constant slope. Okay? So that, again, replace it with what it is, velocity. So the velocity is constant. All right? And if the velocity is constant, that means it's not speeding up or slowing down, so the acceleration is 0. Okay, next one up. Now we have a positive slope. The slope is positive. Okay? We replace the word with what it represents. The velocity is positive. Okay? Again, it's a straight line. If it's a straight line, it's not curving up or curving down, all right? Then there is no change in the slope. The slope is constant. Replace the word slope with what it represents. The velocity is constant. Okay? And again, if the velocity is constant, it's not speeding up or slowing down, there's an acceleration of 0. All right, how about that one? It's a negative slope. Slope is negative. Replace the word. The velocity is negative. Okay? It's, again, going to have a constant slope. All right? Therefore, the velocity is constant, and you have an acceleration of 0. All right, this one is a positive slope. It's still going up. So the slope is still positive. The velocity is positive again. All right? This time it's curving up. It's an increasing slope. Replace the word with what it represents, and the velocity is increasing. So now we have an increasing velocity, meaning it's speeding up. Okay? So you have a positive acceleration. All right, now look at that one. Is it a positive or negative slope? It's still a positive slope. So the velocity is positive. Okay? The slope is also decreasing this. It's pointing up higher here than it is there. Okay? So the slope is decreasing. Therefore, the velocity is decreasing. So what type of acceleration is that? It has negative acceleration. All right, next. Now we have a v versus t. The slope of v versus t represents acceleration. Okay? So let's start with just saying saying something about the slope. The slope is 0 because it is a flat line. Okay? Therefore, the acceleration is 0 because just replace the word slope with acceleration. All right, how about this one? This is a positive slope. Okay? So it has a positive acceleration. There you go. All right, this is a negative slope. Therefore, it has acceleration is negative. Okay? So you're just replacing the word slope with what it represents. All right, now this is an acceleration of 0. I'm sorry, this has a positive acceleration. There's the slope of 0. All right? Acceleration is just constant, is all we're going to do. And we're really not going to have many questions where acceleration is changing. Okay, maybe later down the road, but not now. All right, these are the 3 things you have to remember. Slope of position versus time is velocity. Slope of velocity versus time is acceleration. And the area under a velocity versus time graph is displacement. So what that means is if you see a graph on a test, it probably is really asking if you know what the slope represents. Okay, so if you see a position versus time graph, all right, expect that it's really going to be asking about the slope and getting velocity. If you see a velocity versus time graph and asks about acceleration, it's really asking, do you remember that the slope represents acceleration? Same with the displacement. If it asks for how far you've traveled, it probably really wants you to remember that you need to calculate the area underneath the graph. Okay, that's it. Thank you.